So, if we continue with that, then mortality curve for lamps looks something like this. We plot percentage of the we plot percentage average life and this side percentage survivor. So, these are manufacturers find out from their test experiments and all that. So, at the moment first at the starting point you will have 100% lamp. Then as the time passes, average life is defined as that time when survivor is 50%, right, 50% is survivor, 50% has failed, 50% is survivor, 50% has failed. So, typically the curve is something like this. Initially the failure rate is very slow, then suddenly the failure rate increases, and once it increases then it goes at a very fast rate, because this slope you can see is steep, and then again last at the end few lamps will last for longer period of time. So, it is complementary S curve actually, 100% surviving in the beginning, slowly there is a failure and then rate increases and suddenly all lamps starts, many lamps starts failing, but few lamps will survive for very long period of time, right. So, basically cumulative distribution related to that kind of scenario. So, one complementary S curve. So, we define the average life as that one where 50% of the lamps are surviving. Now, then one can find out what is economical. Do I wait for every lamp to fail and then replace as and when they fail, or I do a bulk replacement at some point of time when you have large number of lamps. I can do a bulk replacement when I have large number of lamps, right, and that might turn out to be cheaper, Why? Because when you do a repair, as and when it fails, the cost is higher. Every time you have to, the time is, a lot of time is wasted. Every time you have to call the people engaged in repair work, they will set up, do the repair and then again go away. So, the time spent per lamp is much higher. So, therefore, cost is higher. Now, one part is the cost of the lamp itself, other is the labor cost. So, labor cost is usually higher, cost of the lamp will remain same. Something similar which I said about the roof covering repair. So, essentially the cost will be same. So, let us see. So, we call it spot replacement or bulk replacement, So, spot replacement is when I am replacing whenever there is a failure. So, the total replacement cost will be C per lamp, let us say cost of lamp is C, and total cost C lamp is equals to cost of the lamp and cost of spot replacement, right. So, C is the total cost, which is L plus S. L is the cost of a single lamp, S is the spot replacement cost, essentially labor or whatever it is. If you have bulk replacement cost, then the objective is to avoid the costly random use of labor force involved in replacing lamps individually. That is the idea, because randomly if you call them, labor cost is higher. So, mortality curve would show that after 80%, average life, the average failure rate increases very rapidly. That is what I was mentioning. And it is possibly generally accepted that all lamp at this time generally, maximum, if I want to find out the economy, possibly at 80 or 75% of the survivor when there is a, maybe I replace all of them. Let us see how it is. So, we define, as I said, spot replacement C is equals to L plus S. Now, what about the bulk replacement? This will be also L plus per lamp, this is per lamp, this is S per lamp and this is a per lamp. Similarly, cost for bulk replacement cost will be L plus B, because B is the bulk replacement cost per lamp, which will be smaller than S, because now setup cost etc. is single time. Somebody comes, some agency comes, it starts from one end and just replaces them. But there is one thing happening, because I will not bulk replacement, I will do at certain periodicity. So, then part of the lamp, the fraction that fails between the period of repair, let us say that is f, because I am talking in terms of percentage survivor. So, f fraction, f percentage fails between two cycles of complete replacement, bulk replacement. Then this f would actually mean that I have to do spot replacement for them. So, when I am doing bulk replacement, I cannot avoid spot replacement completely, because some of them I will have to replace, some of them I will have to replace, spot replacement I will have to do. I cannot avoid bulk replacement, even if I do, I cannot avoid spot replacement completely. Between two periods of complete replacement, bulk replacement, I have to do some spot replacement. Let that percentage be f. So, f divided by 100 into L plus S, because that spot replacement cost per lamp, that will be the total. So, cost of bulk replacement will be this, and therefore, I can find out what is the value of f corresponding to, what is the value of f corresponding to, what is the value of f corresponding to the decision that bulk replacement is cheaper. So, what I do? I equate this. So, I simply equate this, L plus S, if this is same as L plus B plus f by 100 into L plus S, then I will go for, no, this should be less or equals to. So, limiting case, let me take B as equal and find out the value of f. So, f would work out, if f is in percentage, f would work out, right, f would work out L plus L plus S, I can bring it in this side. So, I will have 1 minus f by 100 into L plus S must be equals to L plus B. I bring it on this side, L plus S is common into 1 minus f by 100. Is this algebra okay? I think it is okay. So, you can find out that L plus S. So, it is essentially, I will write it like this, L plus S is equals to L plus B plus f by 100 into L plus S, because that is the cost of bulk replacement, and when it is the same, well, or this is less, I can take a decision, right. So, what I do is this, if I, it will be 1 minus f by 100 into L plus S is equals to L plus B. In other words, 1 minus f by 100 is equals to L s by L plus B. So, this I cancel out, this is L plus S. So, this this or I can get an expression for f, simply expression for f will be from this, expression for f will be, I can get an expression for f from this 1 minus f by 100 it was. So, both sides, if I subtract 1 or if I take it on to the other side. So, I get 1 minus L plus B divided by L plus S is equals to f by 100, and this is nothing but L will cancel out. So, I will have, so I will get an expression of this in this manner. Let me see, just write it somewhere. So, let me erase this out portion, erase this portion out. So, I will get an expression of this kind, simply I will get an expression of this kind, I will get an expression L plus S minus L minus B divided by L plus S is equals to f by 100. So, this cancels out. So, S minus B divided by L plus S. So, f is equals to 100 into S minus B divided by L plus S. So, this difference actually, how much is the difference between S and B, that will dictate when do I do. So, once I have found out F, I have found out F, let us say I find out F is equals to 20%, right, F is equals to 20%. So, I can go back to this graph, I can go back to, so F let us say is 20% or 15% or whatever it is. So, I can go back to this graph, let us say this is my, this is F is this much. I mean what I have found out, this 25% or something like this, let us say in this particular case. So, percentage F is the percentage failed, fraction failed, percentage failed. So, 1 minus F or 100 minus F is the percentage survivor. So, percentage survivor I know is here, corresponding to this what is the life of the a percentage of average life at which I should do bulk replacement, I can find out. So, I can find out, so for example, this is 80%. So, if 25, I mean this is how much, this is 80. So, maybe 75%, this one is 25% I have found out. Corresponding to that, it would show that I should do actually a bulk replacement at around 80% of the average life. So, even lamps are good, but still I might simply replace them, because after that the rate of failure will be fast, and I have to possibly call people every now and then, and it would have both ways. There could be indirect cost involved also, particularly in a factory the indirect cost will be very high. Why? Because the production might get affected. Maybe it is in a hospital, there can be a serious problem. So, depending upon the occupancy type or otherwise, I might decide to actually do a bulk replacement, even taking into what is called disruption cost into account, indirect cost into account. So, bulk replacement, that is what, and if you plan, then plan only this time, this you can do. So, replacement policies are to be planned and not based on just emergency, somebody calls you, things are not okay, you start repairing, that is not the best way to do things, right. Okay. So, that is the example. Now, how do you find it out actually? How do you find it out? For that you have to actually find out the percentage survivor, right, and you might find age. So, percentage scrapped, if you can know the percentage in some other, for example, many other items, say precast lamp posts, they have longer life. We are not talking of 1 year, 2 year life, sometimes it is much longer. Precast lamp posts, you might find that they start, once they start falling, once they start giving up, cracks coming or something, many of them will start showing cracks, and you might do a bulk replacement. Tap washer, in a large area, number of taps are there, let us say, you will find that if you have replaced all of them, suddenly initially few will fail, then suddenly all starts failing. So, there can be several other situations where mortality curves are similar to the lamp mortality curve. I have shown you one model, but you can look into other models also, but the data should be available. We do not have this kind of data for many situations. So, you have to actually innovate, find out where you can apply these models, but these models can be applied and you can find out the renewal cycle. So, how do we find it out? For example, if I know the percentage, how do I find out? First I find out, today I have put in X amount in service, I call that 100%. How much is the percentage surviving after 1 year? Then how much of the percentage of that surviving next year and next year and next year and next year? If this data is available, I can find out average life. For lamp, they do experiments in the lab, there are laboratories where they will subject it to higher voltage. As long as the failure mode remains same, you can use rules, what is called there are cumulative damage theories, so you can, from that cumulative damage you can count at higher voltage. So, you can actually find it out, there are ways of finding out, we will not look into that right now, but some cases where it is over a long period of time, you find out how much percentage has been scrapped after 1 year, how much percentage has been scrapped after 2 years. So, average life you can find out might work out after 7, 8 or 11, 12 years. So, you might generate a table of this form, which will show that age, this column is age 0, that is starting point, and between percentage scrapping after, so starting point is 100, fraction 100%, and number scrapped is 0.0103 percentage or fraction you can talk about, survival is 0.97. So, probability of scrapping therefore is 0.3, because out of 100 only 0.3 has been scrapped. Next year 97 remains to start with, then you find out that some 0.388 certain percentage has been number scrapped, survivor is this. So, probability of scrapping again, because it will be now on 97%, 0.97. So, 0.97, 0.3038 or something has scrapped, at 100 how much it is. So, these probabilities you can find out, and you might find everything has been scrapped after 11 years or so. So, if you form it in a tabular form, you can find out the this was 100% here or 97 survived. Average survived on this year would be 1.97 divided by 2, because in the beginning of the year 100% was there, end of the year 97% was there. So, on an average 100 so half of that 1.97 or 197 divided by 2, which comes out to be how much, 9850. That is the average survivor on that year. It could be 1 year or 5 year even, depending upon the situation, but 1 yearly situations are what is our concern usually. So, average survivor on that year was between the two, starting 1 and 97. So, average is in between. Similarly, starting 97 and then survived 93 survived is 90.9312. So, average how many survived on that year, that you can find out. So, if you sum up this average, you will get the average multiplied by year, that many average year, average into 1. So, if you sum this up, this cumulative is the sum, right, not this cumulative is not the sum. So, from backward you can go on accumulating 7.3. For last 2 years survival was cumulative sum was 0.073 plus 0.39. So, it will be, you can add this up and cumulate from this side, right, cumulate from this side, and you will find out that basically what you are doing is this one survived 11 years, 0.03 survived 11 years, 0.04 survived 10 years, right. So, this survived. So, if you sum this up, cumulate this, in a way this gives you the average life, because this multiplied by 1, this multiplied by 1, that is the average life. So, if you sum it up, that gives you the average life. So, average total number of years, average life you can find out. So, actually most of them, many of them survived till 11 years. Average how much they have survived, that you can find out by accumulating back. So, in case of such ones where you have data available, you can actually find out the average life, or plot even the mortality curve where 50% survived, that would be your average life, and use the same. So, LAMP is usually for shorter period of time. Earlier LAMPs would have been 6 months maybe, life would have been of that order. Now, the life has increased, but still similar concepts can be applied, and it can be applied many places where the failure, consequence of failure is very serious, or they have financial implications, and also you can predict the renewal. So, I have shown you a couple of models. One, I have shown you the models of roof covering, I have shown you the models of painting, external or internal. I have shown you the case of replacement of, let us say, flooring, and now lamp replacement or some other replacement where, let us say, the electric post or something of the similar kind. So, you can actually find out the renewal cycle of many items in the building, but for that you have to keep the data, you have to maintain the data and record it over a long period of time, and that system should be in place, recording system should be in place, right. Okay. So, once you have done that, then I can plan my maintenance. Once I have done that, I can plan my maintenance actually, right. So, main thing is when I do such kind of bulk replacement, I get actually cost saving, right. Lower cost, in that there is less non-productive travelling time, the equipment is set up less frequently. So, your cost of equipment setting up or equipment hiring time would be less, may be planned in advance. So that if you, for example, it would be a good idea to do a lot of maintenance during summer vacation, hostel maintenance in summer vacation, because the students would be there. Or if you know the lean period in a hotel, not the season. So you can, or in a some sort of a maintenance, you can coincide with other maintenance. For example, machine maintenance is required, so you might coincide with that kind of thing. So planning is possible, may coincide with one of the fittings, cleaning, etc., etc. The value of illumination also will be higher in case of lamp maintenance, because you are replacing them by the new ones. The overall appearance is better, etc., etc., and this goes for every other such renewal you do, right. So therefore, I can, when I have decided on renewal cycles of many items and got a cost profile, then in such situation what I can do, I can actually plan my maintenance system rather than keeping it emergency on the basis of emergency, which will be costlier and it will be economic. A best maintenance system will plan around 95%, and we can do that actually, and 5% is left to ad hoc. You cannot avoid ad hoc. In such system you cannot avoid ad hoc. If you see, even if you are doing budgeting for, let us say, laboratory budgets or even national budgets, many a times you have some cost called planned cost. Then you have got some expenditure which are every year they recur, recurring expenditure, and then you have contingency in the recurring expenditure. Now, the recurring expenditure, which is contingency, where you include actually, that should be something like 5% of the total, or something, a lump sum you can always put, because you might have actually been able to kind of keep a track of them or data of them. Data are available, data is available for many years, that okay, typically this is the percentage of cost of the non-planned items. So best would be 5% ad hoc, and I got to do long term planning, right, and it does help me yearly budgeting, and it is also but then this needs inspection. I must do an inspection to verify my planned verify my planning. I would have planned it, so it should be, I should be able to verify my planning, right, that what I have planned is going on well, all right, because sometime it may happen. So cost of inspection is important, and inspection cost saves your repair cost sometime. Inspection cost saves your repair cost sometime. So in that context, or even otherwise in the context of maintenance, one cost is very important, cost of disruption. This model I am talking about is important because I am also involving now cost of disruption cost, right, cost of disruption cost. You see, if you are doing inspection, you will be actually disturbing the function or activity. So therefore, there is a cost of disruption involved. In many places this will happen. So cost of disruption is involved. I will come to this a little bit later. Let us look at this model first, then I will come to those two diagrams that I am talking about. I want to find out what should be a number of inspection on certain things. Let us say it is per annum, but it could be per 5 yearly also for some other item. So this cost reduces exponentially. If I increase the number of cost of emergency repair or number of emergency calls, if any is the number of emergency call, it is seen that if I do inspection, this would be Ni, where Ni is the number of inspection. If I do more number of inspection, less will be my number of emergency calls. For example, electrical system, let us say, right. So if they periodically check the short circuiting and things like that, where there is somebody checks them, then failure would be relatively less, and more inspection you do, this number of emergency calls tends to reduce down exponentially. So it's something like this, when I have possibly 0 inspection, it is something like this, 0 inspection. So, Ni versus Ne. So, this is A, right. So, when Ni is equals to 0, this is equals to Ne is equals to A, and then it reduces in this manner. Then it it will not be, it will be asymptotic. So, as n tends to infinity, this will go to 0, this will asymptotic to x axis. So, it reduces in this manner. So, n is the number of emergency failure, and supposing my cost of emergency repairs is C, then my total cost will depend upon CE NE plus cost of inspection into number of inspection, and NE can be replaced by this formula. So, that is what I have done, CA e to the power B Ni C Ni, and then minimum, what is the optimal number of inspection? Simply differentiate this total cost with respect to Ni, and you will find that it comes out to be, if I differentiate this, then it will come out to be C A e to the power minus B Ni is equals to C I inspection cost. So, therefore, I can find out Ni simply by taking like e to the power Bn, or if I take ln both sides. So, Bni will be equals to C ln of Ci by ln of ACI, or no, ln of ACE. Am I right? Let me just do it again, write it clearly for you, yeah. So, what I am trying to say is, you see the total cost is cost of emergency, which is A e to the power minus B Ni plus cost of inspection into Ni. Differentiate this with respect to dni, put equals to 0, then you get minus Ce B, right, am I right, B A e to the power minus B Ni is equals to, or plus Ci is equals to 0. So, you can find out Ni then, which will be e to the power minus B Ni will be equals to Ci by Ce AB. Am I right? So, if there is that, take ln of both sides, you will get minus 1 by B ln, this equals to Ni. So, Ni is equals to minus 1 by Bi Ci by Ci Ce AB. So, one can find out the optimal number of inspection required, which will make it cheaper. Now, you can add this one, you might add this C might also include what is called disruption cost, because emergency suddenly you stop the activity, there will be disruption cost, and this formula is given here. So, this formula is given here, minus 1 by B log C A B etc., is equals to Ni. So, one can obtain this, So, one can obtain this, is it correct, or is there something wrong? B Ni, so ln B Ni, yeah, Ni will be this by, that is right. So, this is the formula. Okay. So, one can obtain the optimal number of inspection required, one can obtain the optimal number of inspection required. Similar sort of situations can come in many other places, where you bring in the annual cost of repair, annual consequential cost, that is your disruption cost, then replacement cost. So, actually you can model them, find out the total cost for alternative, like we did it for bulk replacement or for this one number of inspections. So, you can actually find out the total cost should be equated, and then differentiate if required to find out the number of inspection. So, disruption cost one may take into account, right. Okay. So, that is what it is. So, we now, all right. So, do you have any question related to this? Otherwise, we will look into the inspection, role of inspection in the overall maintenance scheme, right. So, do you have some question? We will answer, otherwise maybe I will take 2 minutes to explain this two diagram and then we will break. So, you see role of inspection is here. Basically, I have a 5-yearly plan or 60 years plan I have talked about. In that there is 5-yearly plan. Inspection has to be done every year before budgeting. The purpose is to see whatever I have planned from 5-yearly long term plan, is this deterioration has actually occurred or is that the condition has gone bad? If it has gone bad, then I must be doing the repair, otherwise I might delay it for the next year. So, when I do yearly budgeting, before that I must do the inspection. So, what I do, I first find out I have a planned inspection, then I find out for each of these items that I expect that there will be some problem, whether work is necessary or not. So, there is the decision box, work necessary. If it is yes, then I find out what is its priority, and if its priority is normal, then I'd like to do it in whether there is a budget, is within the budget or not, again a decision box. If it is within the budget, then I will go on doing it in the overall plan, and if it is priority is urgent, then I have to put it in monthly plan, that is quickly next month I should do it. And if I find it emergency, then maybe I have to do it tomorrow or in a week's time. So, even inspection you do, you see in the time during which month of the year, March or April, March or April possibly your financial year starts, whether you would like to do it in December. If it is something you can do in house, but emergency, because your workforce should be meant only for emergency works, otherwise you would be giving it to contractor. So, if you are giving it to contractor or agencies, because it is not worthwhile to maintain a large workforce for work which is not continuous, right. So, if you already planned most of your things, you will outsource them, give it to agencies from time to time, but when you want to give it, that will be decided by you. If it is outside the budget, then no, leave it for the next year, because it may not be then emergency. It may also happen that if it is not, work is not necessary, you keep it that next year I will again inspect it. Sometimes you can take the user's request also when you are doing inspection, because user has requested, and you might say, okay, if it is just check whether it is necessary, make a decision. If it is necessary, put it, find out the priority. If it is not necessary, send back to the user, say that we will do it sometime later on, at the moment you are not doing it. So, during inspection period you can take it, and then this is how you can actually, this is where the inspection lies in overall scheme of things. So, yearly inspection is a must, yearly I said, but certain things you can even do inspection more than once in a year if the cost is, you find the inspection or you are optimizing the cost, emergency number of emergency calls are reduced. Sometime you might do it more than that. So, therefore, role of inspection we have defined, and then in maintenance management we will have two things, therefore, that is what we have understood, and we will break after this. Two things: one, a large chunk will be planned and a small chunk will be unplanned based on users request and things like that. So, first one we call it schedule maintenance, because I will schedule them. Second one I call it contingency or ad hoc maintenance, which will be based on users request largely, or anything what emergency happens. So, the schedule maintenance will have long term program. Right in the beginning I found out the cost profile, and I know every 5 years I have found out the renewal cycle. So, between these 5 years what I am going to do, that is a long term one. Then from long term to yearly planning, right, annual planning, and that how much I would be spending this year would depend upon annual inspection. And then from there I do the budget for that particular year. I do the budget, but in the budget I must keep some provision for contingency. That is what we normally do, some provision for contingency that we will have to do, all right. And then you find out even if it is within budget this year, would you like to do it with your own manpower, or give it to contract? If I have sufficient time available, that means I can start this work maybe sometime 3-4 months later. I have time for giving it to contract, then I give it to outside agencies, because I may not have that much of staff. I do my staff planning also on this kind of basis. If I have done maintenance planning properly, then staff planning also I can do. So, that is what the thing. Then if it is something very emergency type, time is not available, from my inspection I have found out, then I have to see whether I do it in monthly program or weekly program. If it is urgent, within monthly program, if it is emergency, within weekly program, right, or then daily program and so on. Similarly, I take users request also in between. So, I keep some provision for users request, and then in there I find out what is it, whether it is necessary. If it is not necessary, put it back to the user saying that okay, we will do it sometime later on. Find out priority, normal, do it in the whole year, urgent, do it next, within months you plan it, and emergency might do it into weekly and daily programs. So, that is the overall scheme of maintenance, scheduled maintenance or planned maintenance scheme, right.